And we're back on Baja One by Destino. I'm your host, Dana Jimenez, and here with us our guest, Dr. George Smoot, and we're having the most fantastic and interesting conversation. And you can also listen in the
Just
future.
exaggerate a little.
No, I'm not exaggerating. This is pretty awesome. And then you can gonna be able to hear it also on our podcast on our webpage, and destinoloscabos.com, and you can also visit georgefsmoot.com for more information. So, Doctor, shall we talk about?
Okay.
This is your show. What
All
would
right,
you
this
like
is
to
my
talk
show.
about?
No, not quite.
You're
So,
the boss.
I'm a little bit down or off today, and the reason is when I got up this morning, I started, looking at my emails and reading the news, and there was an obituary for Arno Penzias. You probably don't know who Arno Penzias is, and I'd say probably no more than 5% of your listeners would know, but Arno Penzias and Robert Wilson got the Nobel Prize for discovering what we call the cosmic background radiation, the radiation that proved that the universe came from a Big Bang. And he was somebody I knew and looked up to. It's like when you're young in a field and there are people who were the founders of the field. He was the kind of person that when I started out as a grad student, even an undergrad and then a grad student, that I was looking up to him and so forth. To explain what this means, if you look out at the sky at night, it is dark. This much brighter here in the sunlight, right? Why is it dark? The answer is, if the universe, you can think the opposite, if the universe were infinite and had lasted forever, no matter where you looked, your line of sight would end as a star, and the night sky would be as bright as the sun. It would be quite toasty and everything, but it would be very light at night. So already we know from our own eyes that we look out at the sky, the universe is finite. Okay, now that's not too surprising before that, because there was arguments, 50 years before that said there's only one galaxy and the whole rest of the universe is whatever. Now, this was a problem that even vexed people back as far as Newton. He had a problem that he realized his laws of attraction meant that if you just fill the universe with stuff, it would collapse. So he wanted to make it infinite and make it go in all directions. And that turns out it can be okay, except it's unstable. You perturb it, and then you start local collapsing and so forth. And that's actually what we think happens in the universe now, is that it was pretty uniform and there were little perturbations and then there are local collapses, and that's what my work was about. But Penzias and Wilson discovered this, and it's one of the things that I chose to do research on, to study this radiation from the beginning of the universe, to explain how it's possible that we have the universe we see today. Because they look out and they saw the whole sky was uniformly covered with what we used to call the universal background glow. We had a computer named UDBUG, which is Universe Diffuse. Bad sense of humor. And what they saw was, no matter where they looked, there was this uniform glow of radiation coming from the universe. Now, how could that be? Well, first of all, they were at the right place at the right time. They were hired to be radio astronomers by Bell Telephone Lab, which was considering to make satellites so that you could send telephone and TV and other radio signals up to satellites and then back down to the ground. Because before, the only way you could send them was by cable, and you had a few undersea cables, but it was limiting what's going on. They wanted to be able to send stuff by satellite. But they needed to know how bright was the night sky, how much noise was there, how much background. If you're trying to find something in the sun, it's much harder than trying to find it in the dark sky, and it's got a bright light. And so they hired these guys to do that, and they were very good and very careful. They did this series of experiments with this big radio telescope that Bell Telephone built for them, and they built a special device which has got a liquid helium dewar in it, so that's 3 Kelvin, 4 Kelvin normally under regular atmosphere. And they fixed everything up. They did an incredible experience because they kept finding there was this background, this three degrees above absolute zero, 3 Kelvin, right? So it's centigrade. They carefully did all these tests. They cleaned the pigeons out of the antenna and cleaned the antenna. They took the receiver. They did everything, and they kept finding that no matter where they looked, there was this glow. In a few places, like on the galactic plane, they saw a little extra signal, but that was it. That is proof that at one time, now when you understand it, that at one time the universe was as bright as the sun. In fact, it was brighter, but at that time, there was a time when it, no matter where you look, it was as bright as the sun. But the universe has been expanding ever since then, and it's expanded more than 1,000 times since that epoch. And the wavelengths of all of the light have all been stretched by 1,000 times, and they've moved from the visible down into the millimeter microwaves, just a little above your radio waves, right? Your centimeter wavelengths. It's quite incredible. So you have this light that came from when the universe was extremely younger and smaller than now, and in sort of human terms, it's like 12 hours after conception for you now, compared to you now. And that means it's really light coming from the embryo universe. And I understood that. I decided that was a good thing to do research in. Joe Silk, who was at Harvard at the time, a graduate student at Harvard at the time, he was finishing up for his thesis. He was saying, how does a galaxy survive that? If you take our galaxy and put it into a big sun, what happens to it? Well, it gets melted, it actually vaporized, and it falls all apart. How do the galaxies make it through this primordial fireball to the present? I knew at that point that if you could study that radiation and understand it, it was going to be important. Either it was something new making that radiation, or something, there was a primordial fireball, and it's going to be the secrets of the universe, right? How can you go wrong? Right? So you pick that for a topic. And so then I started going to conferences over the night, met Penzias and Wilson, their various conferences, and their personalities were extremely different. One was very aggressive and very, pushy and so forth about various things. But the other one was very nice, as I could do. With his very first paper, got him a Nobel Prize.
Oh my goodness.
It's pretty easy. You wrote one paper in your life, you have a Nobel Prize. You're set for life, right? You got a professorship, and then you're all done. Anyway, I had a really interesting experience with him because we were at a conference in Copenhagen, and they arranged an outing for us to go by small boats to heaven. So Heaven, H-E-V-E-N, is an island that the king gave to Tycho Brahe to do astronomical observations. And he built a place called Uraniaborg. Unfortunately, he built this big thing, and he put the astronomical observatories up on the second floor out on these porch-like balconies, and so it vibrated a little bit. But Tycho Brahe is the one that took all the data that eventually Kepler got his laws out of. So we were going there, we're riding this boat, and he's holding on like I was holding on those bouncy hovercraft boats. And I didn't appreciate it at the time. I was just so glad to be able a chance to talk to him privately. He's thinking, oh, don't let me fall over in the water. But he was very nice, and he's always been nice. And it's quite amazing that it wasn't that other people hadn't seen evidence like this or something. They just did a really careful job and ruled everything out and said, yes, there is this stuff coming. And people jumped on it immediately and said, okay, this means there was a Big Bang, there was all this kind of stuff. And there were all these fights that went on between Gamow and Fred Hoyle and so forth. But this kind of was the beginning of the end for the stuff. I kept running into him periodically, and then I didn't see him for a while. He sort of disappeared. He stepped down as he was head of Bell's lab for some time, and he disappeared. And then I ran into him at a conference in South Bay, San Francisco, and turns out he was running basically a venture capital firm that was, putting money into alternative energies, because this was 2 energy crises before that, and he had picked out various companies and got people to invest in them, and he got a piece of it. So, and he was running that, and he was very famous in southern San Francisco area, Silicon Valley area, for running this investment firm on alternative energies. And they didn't know he had the Nobel Prize, right? It's like that. And he started talking to me more as an equal, because I just got my prize. And so that's one of the changes.
Nobel Prize to Nobel Prize winner.
Yeah, but the fact is, I think he was missing the old days when he was doing science and, having the excitement of learning about the universe instead of being out there growing for money. But he apparently made quite a lot of money with his venture capital firm, at least at the beginning. He had basically Alzheimer at the end of his life, and then he died from that. But it just brings up a bunch of stuff for me.
I'm sorry that you had that passing today. I'm so sorry.
Well, it hadn't happened a day or two ago, but today was when I first learned of it. It's the kind of thing where you see a whole mixture of personalities and work they've done and what's going on, but it's the passing of a major milestone. It's a big thing. But one of the things that Arno Penzias had convinced me to do was take one of the, I'd save pieces from the satellite that we made prototypes a lot of stuff, and I'd save pieces, and some went to the Smithsonian, some went to my laboratory, but I saved one, and he convinced me to give it to the Deutsches Museum. And he said he had arranged to give the end of their horn antenna, the liquid nitrogen target, the receiver and the switch and so forth, and the chart recorder on which they recorded their data. Do you understand how primitive that was? They had a pen drive chart recorder, and that's how they recorded the data. And they said, here it is, look at liquid helium. Here it is, looking at the sky. Here it is, looking at room temperature. And it's on there, and you can see their handwritten notes on the thing. It's in the museum. He said, you should put your stuff in. And he said, when I was a young boy, I went to the Deutsches Museum, which is the science and technology museum, and I saw how ships are built and how they're made and how this has happened, how airplanes are. Also, this made me interested in being stuff. I found out later that when he was 6 years old, his family was arrested by the Nazis and put on a train to Poland, and Poland refused to take any more Jews at the time and sent them back. And so then he was put on a kinder train with his younger brother and went off to live with families in England and so forth. And then his family, his mother and father, managed to get out, and they reunited and they moved to the United States. And he told another person, which I hadn't known before, that he did it because he thought it was good for the young kids to see that, but also for the Germans to see what they'd missed. But he didn't tell me that part. He just told me it was good because 2 million people a year come there. And so earlier than that,